Electrical resistance and conductance. The electrical resistance of an object is a measure of its opposition to the flow of electric current. Its reciprocal quantity is electrical conductance, measuring the ease with an electric current passes. Electrical resistance here some conceptual parallels with mechanical frictions. The SI unit of electrical resistance is the ohm, while electrical conductance is measured in Siemens, formerly called mhos and then represented by ohm. The resistance of an object depends in large part on the material it is made of. Objects made of electrical insulators like rubber tend to have very high resistance and low conductivity, while objects made of electrical conductors like metals tend to have very low resistance and high conductivity. This relationship is quantified by resistivity or conductivity. The nature of a material is not the only factor is in resistance and conductance. However, it also depends on the size and shape of an object because these properties are extensive rather than intensive. For example, a wire resistance is higher if it is long and thin and lower if it is short and thick. All objects resist electrical current except for superconductors which have a resistance of zero. The resistance R of an object is defined as the ratio of voltage V across it to current I through it, while the conductance G is reciprocal. For a wide variety of materials and conditions, V and I are directly proportional to each other and therefore R and G are constants. Although they will depend on the size and shape of the object, the material is made of and other factors like temperature or strains. This proportionally is called Ohm's law, and law materials that satisfy it are called ohmic material. In other cases such as transformer, diode or battery, V and I are not directly proportional. The ratio is sometimes still useful and is referred to as a chordal resistance or static resistance since it corresponds to the inverse slope of a chord between the origin and in the other situations the derivative may be most useful, that is called differential resistance. Introduction. In the hydraulic analogy, current following throwing a wire of resistor is like water following through a pipe, and the voltage drop across the wire is like the pressure drop that pushes water through the pipe. Conductance is proportional to how much flow occurs for a given pressure, and resistance is proportional to how much pressure is required to achieve a given flow. This the voltage drop, i.e., difference between voltage on one side of the resistors and the other, not the voltage itself, provides the driving force pushing current through a resistor.